Welcome to Aryan tutorials on kinematics of machinery. So in this video lecture, I am going to explain what are the basic terms required to understand about the kinematics of machinery. So let us have a look over the basic terminology. That means the terms required to understand about the kinematics of machinery here. So in the previous video lecture, already we have defined about the machine, and here this machine is formed by the mechanism, and the mechanism is formed by the kinematic chain, and the kinematic chain is formed by kinematic pairs, and the pair is formed by kinematic links. So that means here, for making a machine, initially we require the links, and then we can form a pair, and the pair is formed in the form of chain. And when the chain is made as a mechanism, and when this mechanism is used to do a particular work, then it can be called as a machine. So this thing already we have discussed in the previous video lecture. So here I would like to explain about what do you mean by exactly link, pair, chain, and when these can be called as a kinematic, like a kinematic link, kinematic pair, kinematic chain. And once again we'll be defining the mechanism. So let us have a look about first the kinematic link. So here kinematic link, how can we define a kinematic link? So see the definition first. It is a part of a machine which transmits relative motion from one link to the next adjacent link. That means here it is a part of a machine which transmits the motion from one part to the another part. So whatever the part we are considering, and through which we are transmitting the relative motion from one part to the another part. So those parts or the part can be called as your kinematic link. And especially we are calling it as a kinematic link means whenever it is able to transmit the required relative motion that should be taking place in between two parts. So then only the link can be called as here the kinematic link. Next, we try to have a look or the example which part can be considered as a link here. So this is the two-stroke engine we are considering, and it is consisting of various parts, and each and every part we can consider as a kinematic link. Why? Because the movement of the part will be taking place in relation to which it with other parts here. So here the piston can be considered as one link, and the piston connected to the crank with the help of the connecting rod. Before that, a cylinder which is also considered as a link here. And the next, the connecting rod, which is the rod is connecting between piston and the crank, so that can be also one link, which is a kinematic link here. And last thing is crank. So this crank is also one of the links. And here total how many links are there? One, two, three, four links are there. And the cylinder is a fixed link here. So with respect to that, the remaining parts will be moving in relation to with each other. So these four parts can be considered as a kinematic link. Why? Because a particular relative motion transmission is taking place to get the required work from this two-stroke engine here. So that is about the kinematic link. And next we go for the next element. Sorry, we go for the classification of the kinematic link. So again, there are different types of the kinematic links, and we can classify them into various parts. So we have a look over the main three types of the kinematic links here. So there are three types of kinematic links, and one is rigid link, and second one is flexible link, and the third one is fluid link. So these are the three types of the links we can use for making any kind of the mechanism. And here, what do you mean by the rigid link here? So already you know about the rigid body. In the same way, we can define the rigid link also. So the definition of the rigid link, we can give it as a kinematic link that can be called as a rigid link when it does not undergo any deformation during transmission of motion. So whenever there is no deformation is taking place during the relative motion transmission, so that link can be considered as here rigid link. So rigid body is also can be defined in the same way that already you know. Whenever there is no deformation of the body, whenever you apply any kind of the force, that body can be called as a rigid body. So in the same way we have defined. And what are the conditions for the rigid link here? So basically the rigid link doesn't exist, but we'll be assuming each and every body as a rigid link in a mechanism. So how means here the second reason is If the deformation of the link is negligible, then it can be considered as a rigid link. So what are the part we are considering for making a mechanism? It undergoes the deformation, but the deformation is very small, that can be negligible. So in that case, that part can be considered as a rigid link. Okay, next we go for second type, the flexible link. So in the name it's a flexible, there should be some flexibility. That means flexibility in the form of a deformation. So let us have a look over the definition first. A kinematic link can be called as a flexible link when it transmits relative motion by undergoing the deformation and without affecting the motion transmission. So here, by undergoing the deformation, the link is transmitting the relative motion from one part to the another part. So that is only without disturbing the relative motion transmission, even by undergoing the deformation. So that kind of the link can be called as here a flexible link. So example, we can take belts, belt drives, and rope drives. So example, belt drive, we usually arrange the belt over the two pulleys by giving particular deformation in the form of enlarging it and mounting over the two pulleys. So that means it is undergoing the deformation, and still it is transmitting the power that is in the form of the rotation from one pulley to the another pulley for required work output. So these kind of the belts and drives can be called as a flexible links. And the next we go for a fluid link. So fluid link, here the fluid can be called as a kinematic link. So how means here, you can understand by going through the definition. So here the definition can be given like, when transmission of relative motion takes place through a fluid. Listen carefully. The relative motion transmission is taking place through a fluid in the form of pressure or compression. Then the fluid can be considered as a fluid link. So that means the relative motion transmission from one part to another part is taking place through the fluid by compression or pressure distribution of the fluid. Then the fluid can be called as your fluid link. So let us have an example, that is the fluid braking system here. We can consider fluid braking system or hydraulic press also. In hydraulic press also, with the help of the compression of the fluid only, we will be forming a required shape. And here I would like to give the image for the fluid braking system. So like this, the fluid braking system we can consider, it consists of one cylinder here above and the piston, and here also two cylinders and two pistons, and these two pistons are given with two braking pads that are going to be in contact with the disc that to be connected to the field to apply the brake here. So here when you look at the operation, when you try to push this brake pedal with respect to this pin joint or pivoted joint, this rod will try to push the piston inside the cylinder. So this cylinder is entirely filled with water. Okay, all liquid assume here, not particularly water. So it is filled with a liquid. So whenever you compress it, this fluid will try to apply the force on the two pistons arranged in the two small cylinders here. Then the brake pads will move forward, and then they will come in contact with the disc, then it will apply the brake to the disc. Okay, likewise here what is happening, the motion transmission is taking place through the fluid here. So here in this case we can consider the fluid as also a kinematic link. So that is the example we can consider for fluid link. Okay, so that is about kinematic link. And next we go for the next basic element, which is here kinematic pair. So let us go through the kinematic pair and its classification again. So how can we define a pair? So normally a pair means we can define it as a two parts connected together. So in the same way we can define, but let us have a look the definition. When two links, those are the kinematic links or elements are connected together to transmit a constrained relative motion, then the pair can be called as kinematic pair. So here exactly when the two kinematic links are connected to transmit a constrained relative motion. So then the pair formed can be called as a kinematic pair. So constrained relative motion we are stressing on that. So constraint means a particular directional motion only it has to allow from one part to the another part. So in that case we can call it as a kinematic pair. A simple pair means two elements connected. When we have to call it as a kinematic pair means when they are connected together to transmit a particular directional motion. In that case we can call them as a kinematic pair. And example, same two stroke engine we are considering here: piston, cylinder, connecting rod and crank. So all these parts can make four pairs here. So what are the pairs we can consider? Means one pair is cylinder and piston. The cylinder, which is the fixed part, and the piston can form one pair, and similarly piston and connecting rod can form another pair, and connecting rod and the crank can make another pair, and similarly crank and the frame, crank, frame and cylinder and the shaft all are related to single link only, because those are in a rigid position like in a fixed position. So the crank, frame, cylinder and the shaft can form one pair here. Okay, so that is about the kinematic pair. Next we try to have a look over the classification of kinematic pair. So how can we classify different types of the kinematic pair? So there are various types of kinematic pairs. They can be classified based on the following conditions. So based upon particular conditions, we can classify the kinematic pairs here. So the first condition is according to the type of relative motion transmission. So the relative motion transmission may be taking place in different types. Based upon those types of the relative motion transmission from one part to the another part, we can classify them into different types here. And similarly, according to the type of contact between the links. So what is the type of contact for the two links we are going to give? Based upon that also we can classify. And the last condition is according to the form of closure of the two links. According to the form of closure of two links means here how we are fixing the two links. So in what way we are going to fix the two links. So based upon that also we have different types. So now we try to have a look over that. So first we go for the condition according to the type of relative motion transmission. So one is as a sliding pair, and second one is turning pair, and third one is rolling pair, and the fourth one is screw pair, and the fifth one is spherical pair. So these are all related to based upon the type of motion that is going to take place in between the two parts, that is two links. And here the sliding means there will be a sliding motion. Turning means one part turns with respect to another part. Rolling means one part rolls over the another part. And the screw pair means one part rotates with respect to the another part with the help of screw threads. And the spherical pair means a different type of motion takes place in between the two parts with the help of the spherical shape we give to the two kinematic links. So let us have a look over a particular definition to each and every pair here. So first we try to have a look over sliding pair. So how can we define a sliding pair? Means here when one element or kinematic link slides over the surface of another element or kinematic link, then the pair can be called as a sliding pair. So it means one part has to slide over the another part. So then the pair formed can be called as a sliding pair. So let us have a look over the example, which is the slider crank mechanism. About this, we learn in further videos. So this is a slider crank mechanism. So when you keenly observe here, it is consisting of one, two, three, four parts. And in these four parts or links, the four and one can make a sliding pair. So how can you say that? Means here this fourth part can slide over the first part during the rotation of this crank AB here. So then 4 and 1, we can say that link 4 and link 1 forms a sliding pair. Okay, next we go for the next type of pair, which is the turning pair. So turning pair means also one has to turn with respect to another part. So what is the exact definition? How can you form the definition? Means here when one element or kinematic link turns with respect to other link or element, then the pair can be called as a turning pair. So simple definition, two times I'm repeating. So now we go for the example here. So same example we are taking, which is the slider crank mechanism. And when you observe here one link connected with the second link, here one joint is given is a pin joint, we can say that. So which allows the rotation, that is the turning of this AB link. So when you give the pin joint, that becomes a revolute joint, which allows the turning of one part with respect to the another part. In the same way, the second link and connected with the third link as a pin joint with a pin joint, and similarly third is connected to the fourth with the help of the pin joint. But there is no pin joint for fourth and one, so that is why it is a sliding pair. So we can say that the turning pairs are link 1 and 2 can form turning pair, and 2 and 3 can form turning pair, and 3 and 4 can form a turning pair. So these are all can be considered as the turning pairs in which one part can rotate with respect to the another part. That means one part can turn with respect to another part. Okay. So next we go for rolling pair. So what do you mean by exactly rolling pair? So again, definition: when one element or kinematic link rolls over the other link, then the pair can be called as rolling pair. So whenever one part rolls over the surface of another part, then the pair can be formed as here. Sorry, then the pair can be called as here rolling pair. So let us have take an example of this is bearings, ball bearings, and here it consisting of two rings which are connected with the help of balls here. So when the rotation happens with respect to another part, so one part will roll over the another part with the help of these balls arranged in between these two rings. So one part is rolling over another part with the help of one intermediate element. So rolling is happening as one part is rolling over another part. So this kind of pair, these are two rings, can be called as a rolling pair. So this is one of the example we can consider. Next, the fourth pair is screw pair. How can we define the screw pair means here? When one element or kinematic link turns or rotates with respect to the axis of another link with the help of screw threads, then the pair can be called as your screw pair. So your turning or rotating should happen for one link with respect to the axis of another link with the help of screw threads. So when the pair formed can be called as here, then the pair formed can be called as your screw pair here. So example we can consider a simple nut and bolt. So the rotation of the nut or turning of the nut takes place with respect to the axis of the bolt here, and that turning is happening with the help of the screw threads. So this nut and bolt can be taken as a simple example for screw pair. And the main example, if you want to consider from a particular machine here, this is the part of lathe machine. So this is entire carriage, and this is the lead screw. When you try to rotate, this black wheel is provided. So this entire carriage will be moving over the lead screw with the help of the threads provided. Internal thread is given to the carriage and the external threads are given to the lead screw. So when you try to rotate it, it will be moving over the lead screw. So these two parts can be called as a screw pair here. Okay. Next, spherical pair. So here spherical pair means when one element or kinematic link swivels or rotates inside the element or kinematic link, then the pair formed can be called as your spherical pair. So here the two parts are connected in the form of a sphere shape. One is internal and another one is external sphere shape, and that which can allow the swiveling or rotation of the one part with respect to the another part in a particular direction. So that pair can be called as a spherical pair. We can take an example of ball and socket joint. So this is one part and this is another part. With respect to this joint, this part can swivel, it can rotate or oscillate also. So that swivel and type of the motion is possible from the spherical pair. So this is a ball and socket joint. We can take an example for the spherical pair here. And next we go for next condition, that is according to the type of contact between the two links. So next condition, based upon that we are going to classify them. So there are two types of pairs, that is a lower pair and second one is higher pair. That is based on the contact. So when we call it as a lower pair means here, when two kinematic links have a surface to surface contact, then the pair formed can be called as a lower pair. So whenever there is a surface to surface contact, then it is called as a lower pair. So examples we can take same, that is slider crank. So when you consider the spin joint, so when you go for the exact part during the giving of pin joint, these two parts can have surface to surface contact, and here also surface to surface contact, and at the C point also surface to surface contact. When you consider this slider over the surface is also surface to surface contact. So here all the pairs are here lower pairs itself. Basically here the condition is whenever you are considering it is as a lower pair, it is going to be a turning pair, like that we'll consider. Okay, so the lower pairs means try to remember that maximum we consider as a turning pair only. And next we go for another type, which is the, sorry, here I am representing link 1 and 2 as turning pair, 2 and 3 as turning pair. Sorry, here I have mentioned different, it should be a lower pair, so try to correct here. And next we go for higher pair here. So higher pair, when the two links have point or line contact, then the pair formed can be called as here higher pair. So how can we define the higher pair? Means when there is a line or point contact between the two elements or kinematic links, then it can be called as here higher pair. So example, we can take cam and follower. So this blue part is the cam and this part is a follower. When you observe here, this is the knife edge follower which is having a line contact with the cam surface. So whenever this kind of the contact takes place, that is in the form of line or point, here the line contact is taking place, that can be called as your higher pair. Next we go for last condition, that is according to the type of closure. So that first one is self closed and the second one is force closed. So how can we define these two? Means let us have a definition. Self-closed pair, when the two links are mechanically connected together to transmit relative motion, then the pair formed can be called as a self-closed pair. So when there is a mechanical connection between the two links which is forming a pair with the help of mechanical elements, if you connect the two parts, those two parts can be considered as a self-closed pair. So example, we can consider this is also slider crank mechanism. So this is the slider which is connected with the help of this mechanical element as a pin joint, and here is one more mechanical element as a pin joint, and here will be also one more mechanical element, that is the pin joint. With the help of mechanical elements we are connecting each and every link with each other. So when this type of the connection happens, so the type of pair can be called as here self closed pair. Next we go for force closed. So what is the definition? When the two links are connected mechanical, sorry, not connected. When the two links are not mechanically connected together, but by some external forces to transmit the relative motion, then the pair formed can be called as a force closed. So what do you mean by that? We won't be using any mechanical element to give the connection to the two elements, but a particular force is causing the contact between the two elements or links to transmit the required relative motion. So in that case, the pair formed can be called as a force closed. So example, we can take the same cam and follower mechanism. So this is the cam, this is a follower, and in order to maintain the contact between the cam and follower, we are using one spring here. Okay, this spring causes the continuous contact of the follower to the cam during the rotation of the cam and during the reciprocation of the follower inside the guide we are providing. So this kind of the pair formed is called as here force closed. Okay, and the next this is up to the classification of the kinematic pair here. And the next we go for the next element, that is kinematic chain. How can we define a chain? Means the simple definition we can give, whenever it is connected in the form of a chain as a cycle, then it can be called as a kinematic chain. So exact definition we can give, in number of links connected together. If first link is connected to the last link to transmit relative motion, then the chain formed can be called as your kinematic chain. So basically for forming a mechanism, we connect the number of links together. So whenever we connect the first link to the last link, then the chain formed can be called as kinematic chain. But when we particularly call it as a kinematic, means when it is able to transmit the required constant relative motion, then it can be called as kinematic chain. Okay, so the example we can consider, this is the four bar mechanism which consists of four links which are connected, all are connected with pin joints only, and which allows the turning motion. Okay, then which leads turning pair only here. Okay, this four bars, when you consider this first link is connected to the last fourth link, then the chain formed can be called as your kinematic chain. And at the same time we can give the definition for the mechanism also. So from this kinematic chain we can produce the definition for the mechanism. So how can we define? Means here, in a kinematic chain, if any one link is fixed out of four links, if any one link is fixed, then the chain can be called as your mechanism. So out of this kinematic chain, here already I've shown the first link is fixed in a position. Okay, so when the one of the links is fixed in a position, then the chain kinematic chain can be called as your mechanism. Okay, so this is about the basic terms required to understand about the kinematics of machinery, and we have covered from link to the mechanism here. Okay, so I hope you understand about the basic terms which are required to understand about the kinematics of machinery. And if you have still any doubts, please feel free to give a comment to my video so that I'll try to clarify your doubts. And once again, thanks for watching my video. Thank you all.